Hi everyone, I hope you are fine. Welcome to another video of Mastercam. So we have already started the module number 6, which is all about the Mastercam simulator and code expert. So in the previous video, we just discussed about what is Mastercam simulator and how simulator works. So today in video, we are going to learn about Mastercam Verify and Verify Adjustments, posting, and Mastercam code expert. So let's get started. So I have already make a model in the Mastercam. We're using the Mastercam 2023 version. If you have a Mastercam 2023 or the later version, so it's same. The GUI is totally same. You don't need to worry about the graphical user interface of 2023 or 2024. Or especially if you have a older version, which is 2022, so don't worry about it. So here what you see that we have a rectangular block, and in the rectangular block we have a rectangular pocket inside. So what I'm going to tell you that the total length of this block is 200 by 100 by 50 millimeter. So the length is 200, width is 100, and the thickness is 50 millimeters. So we're using the metric system for dimensioning all these things, okay? And for the pocket size, we have 100 by 50 by 25 millimeter. So we can say that the 25 millimeter is the depth of this pocket, 100 millimeter is the length of this pocket, and 50 millimeter is the width of this pocket. So what we're going to do is we're going to test the simulator using Mastercam Verify, how it works, and Verify Adjustments. So the purpose of Verify Adjustments is to get to know how much amount of our cutting tool will get into our workpiece and cut down the material. Some of the cutting tools have different specifications. Let me show you. So just going to apply the pocket here. So let me show you. Go to milling toolpaths or go to toolpaths. We're going to apply the 3D pocketing here. So go to 3D pocket, select all these sides and selection. Yes, we have the containment. Select the containment, or we can say that the boundary. Click OK and OK. So here what you see that, let me go and add it. So what you see that there is a tool which is known as the end mill tool, and here we have to define the tool geometry. So what you see over here is the cutting diameter, which is 10 millimeter. I'm going to use a 10 millimeter dia and mill, and its old dia is 10 millimeter. So overall length is 72 millimeter, which means that 50 millimeter is the thickness of the block, and it will come, we have a large amount of length, which is 72 millimeter. So we can do this by this tool. If you have a shorten the length, the cutting tool will collide with this and not able to cut down this part, okay? So make sure that you have a length of tool, what operation you are going to perform, okay? And the main thing is cutting length. So what you see over here, the fluted area, the yellow area represents the fluted area where we have the cutting. Okay, so this length is 16 millimeter. What you see over here, we have a pocket here, and its thickness is 25 millimeter indeed, but the cutting length is 16 millimeter. So how it can be done? So you can see that this length is not enough to cut down this. So you have to select the appropriate tool for your operation. If you have cutting fluted length is smaller and you have a pocket or depth of cuts or depth where the cutting tool reach and able to cut down that material is very deep, the cutter will be suddenly break down or it will damage your workpiece. So make sure you have to set your cutting tool properly or recommended tools you have to select it. So the non-cutting geometry area is we have the shoulder length of 32 millimeters. Okay. And the shoulder diameter is 9.5. Okay. This means that the 32 millimeter is the length where the cutting tool dia is 9.5. Okay. So we have the dia 10 millimeter, the cutting area, and the non-cutting area diameter is 9.5, which means it's under safe point. Okay. And the total shoulder length is 32 millimeter. And the shank dia is 10 millimeter. This shank dia represents that the cutting tool will be hold down in the holder on this area. Okay. So this is the geometry of the cutting tool. So the next thing is you have to define the tool number. So this is my tool number 1. So I can define it that this is tool number 1. And you are going to apply the length offset, and you have to set the length offset. For example, I'm going to apply the length offset of H1 or F1. Then simply define that this tool is H1. And the diameter offset is 1. Definitely the tool number is 1. We have the by default setting at 1. Length offset and diameter offset 1. So head is 0. And how about the cutting speed is 338. This is the default cutting speed set by the Mastercam. So you need to calculate your cutting speed for this operation. So let me define that we are going to cut this material with a cutting speed of 1500 millimeters per minute. And the feet per tooth is cutting according to the calculation is 0.0709 millimeters. Number of Newton we are going to use is 4. And if you want to calculate it, you can automatically calculate it by clicking on this. Okay, so it will recalculate your cutting speed accordingly. So let me say that I'm going to cut this material at 100 millimeters per minute. Feet per tooth is 0.1. Newton is this. And the feed rate is, we have a feed rate of 19,000. It's a so high cutting feed rate. So let me say that feed rate we're going to set is 500, blunt rate is 100, and the retract feed is 2000. It is by default set by the machine. And the spindle RPM we have is 20,000. So spindle direction is clockwise. We're going to use the carbide, and the name of the tool is 10 millimeter. By using this roughing tool and finishing tool, we have to define the step over all these things later. So just finish it. And now the most important thing, we need to verify our tool. Okay, so just right click and edit projection. So here what you see our tool projections. Let me say that I want to put this on this top of this and place it at this corner. Click here. And now you can adjust your cutting tool length and how much amount of tool will be hold down inside this holder. Okay. So this is how you can define it. If you go make it down, you see that the holder will be clamped or hold on this tool, and it will definitely collide with this part. So make sure you have to verify your tool before put the tool into holder and go on operation machine. So this is what we call the verification. So let's enter this, press enter to accept changes, and let's move to other. So the surface parameter we have, this is the clearance, which is set to be 50 millimeter. Let's uncheck. Retract point is 25, okay. And the feed plane is 5 millimeter. So we have a part on the top plane, which is 0 point, and the feed plane is 5 millimeter above this part. So let me set this absolute 5 millimeter. How about the compensation? So we are going to apply the compensation inside this containment boundary. So let's select the inside. How about the roughing parameters? So you need to set the roughing parameters for the operation. We're going to set the cutting tool will cut down the material at each step 1.0 millimeter. And the cutting depth will be incremental method. Okay. The gap setting should be set as correct, broken, smooth, or follow surface. So we set it smooth, motion, gap, keep tool down. And the tool operation will be optimize cut order. Click OK. Go to pocket parameters and you have to select the cutting method. Either you are going to apply the zigzag, constant, overlap spiral, parallel spiral, or parallel spiral with green corners. So you need to set the appropriate cutting method for this operation, just like doing in 2D operation. So I just like to use the parallel spiral operation. We have to set the percentage over step or step over. So we define that we have the cutting tool of 10 millimeter dia. We use the 7.5 millimeter each. Just click OK. So here we have the pocket operation. So let's check it. Go to backplot setting and check your tool. So this is how it operates. This shows that our cutting tool will not collide with the workpiece on any fixture. Okay. There is no such errors. Click OK. And now what we are going to do is we are going to apply the contour operation on the outside. We're going to apply the surface rough operation using the contour operation, or you can do it by using the 2D operation, just like here we have the contour operation. So click on the chain, click OK, and you need to define the cutting tool. So we have the 10 millimeter end mill, and we have to set the cutting speed, all these things here. Go to cutting parameters. We have the cutting parameters of ramp cutting. Set the ramp cut of 1.5. Lead in and lead out is tangential. Linking parameters is absolute, and make it minus 50 millimeter. The feed plane is 2 millimeter absolute. Click OK. So here we have the tool path. But you see, the tool path goes inside. It means that you need to change the side. So go to geometry, click on the chain, right click, and change the side. So after changing the side, you will see here the arrow is going outside in outward direction. This means that the side has been changed. So let me show you again. Change side, it goes inside. It means the chain tool path will be work inside. And if you're going to change this side, it will work on the outside. Click OK. Refresh it or regenerate all the operations, selected operations. It will make like this. So this is how we can generate the tool path and check our tool collisions. I can also say that we can check the gauges. So let's verify all these operations. Go to Machine and Verify. So this is how we can do the operations. We can verify all the gauges. So I hope you understand how we can check our tool, collision and gauges using the tool verification and Mastercam Verify Adjustments. So thank you very much. Stay tuned for more videos.